Hello, this video will introduce you to the factor theorem, as well as we're going to go through an example of how to factor cubic or quartic or higher degree polynomials using the factor theorem. The factor theorem states that for a polynomial p of x, the linear factor x minus n is a factor of p of x if and only if p of n is equal to 0. So this part here makes us think about the remainder theorem. And the remainder theorem says that if we calculate p of n when we're dividing p of x by a linear factor x minus n, then the value that we get is the remainder. Well, it makes sense that if we get a remainder of 0, then whatever divisor we used must be a factor of the dividend. So we're going to use this factor theorem as we factor this quartic polynomial. Now, when you're factoring, you can still use all of the other factoring methods that you've learned before. And in fact, the factor theorem takes a very long time. And if you are able to simplify your expression in any way by using other factoring methods, make sure you are using those as they come up. So here, I notice that all of these terms have a common factor of x, and so I'm going to start by common factoring out an x. Okay. And at this point, the part that's left in the brackets is a cubic polynomial, and we don't really have any other methods of factoring cubic polynomials other than maybe factoring by grouping, but I can see here very quickly that factoring by grouping won't work for this. So we use the factor theorem. And because the factor theorem is based on the definition of a function, and it's using function notation, we first need to define the function that we're going to use. So we're going to factor this piece, or this cubic polynomial, using the factor theorem. So I'm going to define a function for that polynomial. So let p of x equal the cubic polynomial x cubed plus x squared minus 8x minus 12. And if we can factor that cubic polynomial, then we know that the final factored form of this quartic polynomial is x times the factored form of the cubic polynomial. So here we have our function defined p of x. And what we want to do is find a value that we can substitute in for x that will give us the value of 0. So we're looking for this. What value can we substitute in the function so that the function value will end up being 0? And then whatever value works to give a value of 0 when we substitute it in will lead us to a linear factor of that polynomial. So what we do is we try different values. And we don't just try different values randomly. I'll let you think about why this is, but the values that we're going to substitute in, if they're to be a factor, they must be factors of 12. So we are going to start by listing out the factors of 12. 12 or negative 12. I'm going to include both the positive and negative factors here. So we've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay? And so when we substitute in values for p of n, we are going to pick n values that come from this list. So that narrows down our options a little bit. But otherwise, it is just trial and error until you find an n value that will give you p of n is equal to 0. So we can start with the first one on our list, p of 1. And if we calculate p of 1, we get 1 cubed plus 1 squared minus 8 times 1 minus 12. And this gives us the value negative 18. And because this value does not equal 0, what that tells us is that x minus the number that we substituted in, so x minus 1, is not a factor. Okay, then we try the next value, p of negative 1. right? That's the next value on our list of factors of 12. And if we substitute that into the function p of x, we get the value -4. So again, that tells us that x minus -1, so x plus 1, is not a factor. Okay, try the next number on the list, p of 2. And that gives us -16. And because that's not 0, again, we can say x minus 2 is not a factor. And let's try the next value, p of -2. If we substitute that into the function p, we do in fact get the value 0. So therefore we can say x minus -2 or x plus 2 is a factor. Right? So what we know now is that x plus 2 is a factor of this cubic polynomial. So if x plus 2 is a factor of this, we should be able to use polynomial division to figure out what's the quotient when we take this cubic and divide by this factor. So that's our next step. We are going to divide that polynomial, that cubic polynomial p of x, by the factor that we just found, x plus 2. So the cubic polynomial was x cubed plus x squared minus 8x minus 12. And we are dividing that by x plus 2. Okay, so we use our polynomial division. So x times what gives us x cubed? Well, that's x times x squared. And I line up the x squared term above the x squared term in the dividend. Then I multiply x squared times x plus 2, gives me x cubed plus 2x squared, and I subtract. So that gives me 0, and x squared minus 2x squared gives me -x squared. I bring down the -8x and repeat the process. X times what is -x squared? Well, that's a -x. -x times x plus 2 is -x squared minus 2x, and we subtract. So this one gives me 0, and then -8x minus -2x is -6x, and I bring down the -12. X times what is -6x? Well, that's -6. -6 times x plus 2 is -6x minus 12. And when we subtract this, because x plus 2 is a factor of this cubic polynomial, we should get a remainder of 0. So what this tells me is that the cubic polynomial x cubed plus x squared minus 8x minus 12 is equal to the multiplication of the divisor times the quotient. So x plus 2 multiplied by x squared minus x minus 6. So if we go all the way back to the beginning to the quartic polynomial that we were originally working with, we had the quartic polynomial x to the 4 plus x cubed minus 8x squared minus 12x. And we took out a common factor of x. Okay. We now have this factored a little bit further, so we know that that cubic polynomial is x plus 2 times x squared minus x minus 6. And what's left here is a quadratic that we could try and factor further. If the piece that's left here is a cubic or a higher degree polynomial, you may in fact have to use the factor theorem all over again to factor that particular polynomial. But since this piece here is quadratic, we have better ways to factor quadratics than to go all the way through factor theorem again, because it does take some time. So this is a simple trinomial quadratic expression. So the factor form of x squared minus x minus 6 we would look for two numbers that multiply to -6 and add to -1, and we get the factored form x minus 3 times x plus 2. Okay, so now we've got it in factored form. The only thing we can do to write this in a more simple way is we see two factors of x plus 2. So I could write that as x plus 2 all squared. And so the factored form of this quartic polynomial is x times x plus 2 all squared times x minus 3.